Greetings. My name is Mrs. Lyons. Welcome to Chemistry from the Lion's Den. Today's topic is chemical and physical properties and chemical and physical changes. After watching this video, you should be able to distinguish between physical and chemical properties, identify physical and chemical changes, and analyze real-world examples of each type. Let's get started with properties. Properties are characteristics used to describe a substance. We are interested in two types of properties, physical properties and chemical properties. A physical property is a characteristic observed or measured without changing the substance, things like color or texture. A chemical property is a characteristic that describes how a substance interacts or changes into a new substance. Again, physical properties like color, shape, texture can be observed without changing the substance into something new. Chemical properties like flammability or reactivity with other substance describe how a substance interacts with other substances to form something new. Moving ahead to changes, changes are actually processes. Okay, they're processes that alter a substance. Again, we're going to be interested in two types of changes, physical changes and chemical changes. Physical changes alter the form or the appearance of a substance, but does not change its identity into something new. Chemical changes result in the formation of a new substance. So let's look a little bit closer at physical changes. Physical changes, some examples: melting, boiling, breaking, dissolving. Okay, these physical changes change the appearance of the substance, but don't change it into something else. For example, think about water. Water changes from solid ice to liquid water to water vapor. In all of those forms, the substance is still H2O, water. The substance hasn't changed. Chemical changes, on the other hand, result in the formation of a new substance. Some examples of chemical changes involve things like color change, temperature change, the formation of a gas or a precipitate. These are things we'll look for in the lab. Okay, some examples of chemical changes are things like baking a cake, burning wood, digesting food, dyeing or coloring your hair. These things all result in the formation of a new substance. So let's compare. The identity of a substance remains the same in a physical change. It changes, however, in a chemical change. Physical changes are often reversible. For example, you can freeze water to go from liquid to solid, and you can melt water to go from solid to liquid. So that's a reversible change. Chemical changes are rarely reversible. If you think about it, if we look at our example of baking a cake, you can't unbake a cake. So most chemical changes are irreversible. And then finally, in a physical change, we don't form a new substance, while in a chemical change, we do form something new, a new substance. All right, so let's look at a couple of examples, real-life examples, like cooking, okay? In cooking, we have both physical and chemical changes. We can cut something, okay? I could cut some celery into smaller pieces. That's a physical change. Or I can brown something, like I'm cooking hamburger. I'm browning it in a skillet. That's changing the substance into something new, so that would be a chemical change. In cleaning, sweeping the floor, you're just collecting the material. You're not changing it into something new. So sweeping would be a physical change. Using bleach or some other type of cleaner that alters a substance would be a chemical change. And then in industry, some things that you might see if we filter something, okay, like if we have a sand and water mixture and we filter it, that would just be a physical change. A chemical change would be something like polymerization, which is a really big word that means that a bunch of small pieces react and form a larger new substance. So there you have physical and chemical properties and physical and chemical changes. I hope this video has helped to make things a little bit clearer. Take care and be well.